Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corn. So you had some interesting episodes lately talking about electronic warfare and the radio spectrum and everything related to it. And not by way of comparison, but an adjacent question I thought I would like to ask is whenever we're flying, we're told to turn off our electronic devices, put them into airplane mode. And the older explanations used to kind of elaborate a bit, and they'd say that this can interfere with the aircraft's navigation systems. So I'd love to know, Herman and Corn, we talked about the interference or potential for consumer electronic communications to interfere with the military. But in the case of civilian aviation, how is that actually the case? I guess most people would think that whoever is designing avionics and navigation aids would have accounted for this, that even if you make that announcement 1,000 times, there's going to be someone who doesn't know or forgets that their phone isn't on flight mode. But for the majority of, we don't hear about it creating too many catastrophes, thank God. So Herman and Corn, what's the deal there? Is it something that's done out of an overabundance of caution, or is there actually a compelling reason? Why do we have to do it? What's the actual risk to the avionics? Is it a case that if everyone has to do it, or can even one user potentially disrupt the navigation systems through forgetting to turn their phone into flight mode? As you can hear, still working on shifting their code, so it's good to listen to you guys as I rest up here in bed. Over to you two.
Hey everyone, welcome back to My Weird Prompts. We are coming to you as always from Jerusalem, and I have to say, I think the energy in the house is a little bit more relaxed today, even if one of us is feeling under the weather.
Herman Poppleberry here. And yeah, our housemate Daniel is currently holed up in his room with a pretty nasty cold. He still managed to record a prompt for us though, which I appreciate. It is good to hear his voice, even if he sounds a bit like he is talking through a woolen sock.
It is the dedication we have come to expect. And honestly, this prompt is a perfect follow-up to some of the deeper dives we have been doing lately into the radio spectrum and electronic warfare. Daniel was asking about something that I think every single person listening has experienced, which is that moment right before takeoff when the flight attendants come through and tell you to put your phone into airplane mode.
It is one of those modern rituals, right? We do it without thinking, but as Daniel pointed out, the logic behind it often feels a bit opaque. Is it actually dangerous? Is it an overabundance of caution? Or is there some deep technical reason that our tiny little smartphones could actually jeopardize a multi-million-dollar piece of aerospace engineering?
Right, and he made a great point that designers surely would have accounted for people forgetting. I mean, if one person forgetting to turn off their phone could crash a plane, we probably wouldn't have civilian aviation at all. So today we are going to look at the actual risk to avionics, the history of these regulations, and whether the threat is real or just a holdover from a different era of technology.
I've been looking forward to this because it touches on electromagnetic interference, or EMI, which is a fascinating field. And you are right, Corn, it is not just about whether a plane will fall out of the sky. It is about the margins of safety and the complexity of modern signals.
So let us start with the basics. Why did this rule start in the first place? If we go back 20 or 30 years, what was the primary concern?
Well, back then the concern was much more direct. You have to remember that older aircraft systems were often more reliant on analog signals. When you have an analog system, it is much more susceptible to what we call interference. Think about those old desktop speakers you might have had in the late 90s or early 2000s. Do you remember that specific rhythmic buzzing sound they would make right before your cell phone rang?
Oh, I remember that vividly. It was like a little warning. It would go dit-dit-dit-dit-dit-dit-dit-dit-dit, and then 3 seconds later your phone would buzz.
Exactly. That sound was the speakers picking up the radio frequency energy from the phone as it communicated with the cell tower. The speaker wire acted like an antenna, and the internal amplifier of the speaker turned that radio signal into audible sound. Now, imagine that same phenomenon, but instead of a speaker, it is happening in the wiring of a sensitive navigation instrument or the headphones of a pilot.
So in the early days, it was less about the plane crashing and more about the pilots literally not being able to hear the air traffic controller because of the interference in their headsets.
That was a huge part of it. If a pilot is trying to hear a crucial instruction during a low visibility landing, and they have 20 passengers with phones that are all frantically searching for a signal, that collective electronic noise can be genuinely disruptive. But it goes deeper than just audio. Those same radio waves can induce currents in other wires. If those wires are carrying data to a flight display or a navigation computer, you could, in theory, see ghosting or flickering on the instruments.
But Daniel mentioned that designers should have accounted for this. And I know that aviation is one of the most heavily regulated and safety-tested industries on the planet. So, Herman, how do they shield these systems? Why isn't every wire inside a plane just wrapped in a way that makes it immune to a consumer cell phone?
That is the right question to ask, and the answer is that they do. Modern planes are essentially flying Faraday cages in many ways. They use something called shielded cabling. This means that the wires that carry sensitive data are wrapped in a conductive layer, like a copper braid or a foil, which is then grounded. This shield absorbs incoming electromagnetic radiation and shunts it away before it can interfere with the signal inside the wire.
So if the shielding is there, why the concern? Does the shielding ever fail?
It is not so much that it fails, but that it is never 100% perfect. Plus, planes are in service for decades. A Boeing 747 might be flying for 30 years. Over that time, shielding can degrade. Connections can loosen. Maintenance can be done where a shield isn't reattached perfectly. And more importantly, the number of devices we carry has exploded. In 1995, you might have had 2 people on a flight with a cell phone. Today, you have 200 people, each with a phone, a tablet, a laptop, and maybe even a pair of wireless headphones.
Right, so it is the cumulative effect. But I want to push on something Daniel asked. Is there any documented case of a civilian aircraft having a serious incident because of a passenger's cell phone?
That is where it gets tricky. There are many pilot reports documented by the Federal Aviation Administration and other bodies where pilots have reported strange behavior in their instruments that ceased exactly when a flight attendant told a passenger to turn off a device. For example, there were reports of GPS systems losing their lock or the autopilot disconnecting. One of the most cited cases is Crossair Flight 498 in Switzerland back in the year 2000. It crashed shortly after takeoff, and while the primary cause was pilot error and spatial disorientation, the official investigation noted that interference from a passenger's cell phone could not be ruled out as a factor that disrupted the autopilot's flight path.
That is a bit chilling. But it is notoriously difficult to replicate these incidents in a lab, right?
Exactly. You can't just take a plane and start waving a phone around and expect it to glitch every time. It usually requires a perfect storm of a slightly degraded shield on the plane and a phone that is transmitting at its maximum power.
And that maximum power part is key, isn't it? Because when you are at 30,000 feet, your phone is miles away from the nearest tower.
Exactly. This is the part people often miss. When your phone has a weak signal, it doesn't just give up. It ramps up its transmission power to the absolute legal limit to try and reach a tower on the ground. So, when you are in a metal tube miles in the air, your phone is essentially shouting at the top of its lungs, electronically speaking. If you have 100 phones all shouting at once, you are creating a very high energy environment inside the cabin.
So, it is not just one user, it is the aggregate. But let us talk about the more modern concerns. I have seen a lot in the news over the last few years about 5G and aviation. This seems like it is a different beast than just the old analog interference we were talking about earlier.
Oh, the 5G situation is a perfect example of why this is still a live issue. This isn't just about old wires or buzzing headsets. This is about a fundamental conflict in the radio spectrum. In the United States specifically, there was a massive controversy regarding the C-band 5G rollout.
Right, I remember this. It was all over the headlines in early 2022, and even through 2023. The airlines were saying it was going to cause chaos. Can you explain the technical conflict there?
Sure. So, airplanes use a device called a radio altimeter. This is a crucial piece of equipment that tells the pilot exactly how far the plane is above the ground. Unlike a barometric altimeter, which uses air pressure, a radio altimeter bounces a signal off the ground and measures the time it takes to return. This is especially important during low visibility landings like in heavy fog where the pilot can't see the runway. The auto-land systems rely entirely on this data to flare the plane and touch down safely.
And what frequency do those altimeters use?
They operate in the 4.2 to 4.4 gigahertz range. Now, the new 5G C-band that the telecommunications companies bought for billions of dollars operates in the 3.7 to 3.98 gigahertz range.
Okay, so they aren't the same frequency, but they are very close neighbors.
They are very close. And the problem is that some of those older radio altimeters, even though they were designed to listen to the 4.2 range, weren't built with what we call tight enough filters. They could essentially hear the noise from the 5G towers because the frequencies were so close. It is like trying to have a conversation in a room where someone is playing loud music in the next room. Even if you are on a different frequency, the sheer volume of the 5G signal can overwhelm the sensitive receiver of the altimeter.
And if that altimeter gives a wrong reading or fails right as the plane is 50 feet above the runway in a fog bank, that is a catastrophe.
Exactly. That is why the Federal Aviation Administration was so worried. They had to put in buffer zones around airports, and eventually the airlines had to retrofit thousands of planes with better filters on their altimeters. By the middle of 2023, most of the U.S. fleet had been upgraded, but the concern remains as more 5G towers go live at higher power levels. This wasn't about passenger phones, it was about the ground towers. However, the principle is the same. It is about the radio environment being much noisier than the original designers of the aircraft expected.
So, if the concern is now more about 5G towers on the ground, does that mean the airplane mode on my phone is actually less important than it used to be? If I am at 30,000 feet, I am nowhere near a 5G tower on the ground.
In one sense, yes. The direct interference with the radio altimeter from a phone inside the cabin is less likely because of the distance and the shielding. But there is another regulatory reason why airplane mode exists, and it has nothing to do with the plane itself. It has to do with the cell towers on the ground.
Wait, really? So we are turning off our phones for the sake of the people on the ground?
In part, yes. This is actually a Federal Communications Commission rule, or FCC, rather than just an FAA rule. Think about how a cell network works. It is designed around cells. Your phone talks to one or two towers at a time. As you move, the network hands you off from one tower to the next.
Right. It is a very localized system.
Exactly. But when you are at 30,000 feet and traveling at 500 miles per hour, your phone has a line of sight to dozens, maybe hundreds of towers at once. If your phone is on, it is trying to ping all of those towers simultaneously. The network isn't designed to handle a device that is visible to every tower in a 50-mile radius and moving at the speed of sound. It can actually cause significant congestion and glitches in the ground-based cellular network.
That is fascinating. I had no idea. So it is a two-pronged issue. The FAA wants your phone off to protect the avionics from EMI, and the FCC wants your phone off so you don't break the cell network for everyone on the ground.
Precisely. It is a rare case of two different government agencies agreeing on a restriction for completely different reasons.
So, let's look at the actual risk again. Daniel asked if a single user could potentially disrupt navigation systems. Based on everything you have said, it sounds like the answer is probably not a modern, well-maintained plane, but we can't guarantee it for every plane in every condition.
That is the honest answer. Aviation safety is built on the concept of redundant layers of protection. We have shielded cables, we have filtered receivers, we have redundant systems, but we also have rules for passengers. Each of those is a layer. If you remove the passenger rule layer, the plane is still likely safe, but you have moved closer to a potential failure.
It is the Swiss cheese model of accidents. You have all these slices of cheese with holes in them, but as long as the holes don't align, you are safe. By putting your phone in airplane mode, you are just making sure your slice of cheese doesn't have a giant hole right in the middle.
That is a great analogy, and you have to consider the environment of a cockpit. Pilots are already managing an incredible amount of information. Any distraction, even a small one like a weird crackle in their headset or a momentary flicker on a screen, increases their cognitive load. In an emergency situation, you want the pilots focused 100% on flying the plane, not wondering why their display is acting weird.
I also wonder about the social aspect of this. I mean, can you imagine if airplane mode didn't exist? We would have 200 people on a flight all trying to make phone calls at once.
Oh, I think that is the real reason people would riot if the rule was lifted. Can you imagine being stuck in a middle seat for 6 hours between two people having loud business calls? It would be a nightmare. I suspect the airlines are quite happy to have a technical and safety reason to prevent that from happening.
It is a convenient truth for them, but to be fair, some airlines are starting to allow Wi-Fi calling and things like that, which uses the plane's own internal satellite connection. That is different because the phone isn't shouting to reach a tower on the ground, right? It is just talking to a router that is 3 feet away.
Exactly. The power output of your phone when it is connected to a nearby Wi-Fi router is tiny compared to when it is searching for a cell tower miles away. That is why you can use Wi-Fi on a plane but still have to keep the cellular radio off. The Wi-Fi operates at a very low power and on frequencies that the plane's designers have specifically tested and cleared. Interestingly, in Europe, the European Commission ruled in late 2022 that airlines can provide 5G technology on board using special network equipment called picocells. This means for some flights in the EU, the requirement to use airplane mode is actually being phased out.
So, Herman, let us talk about the future. We are in February of 2026 now. We have seen the 5G rollout. We have seen the retrofitting of altimeters. Is this rule ever going to go away in the United States or globally?
It is possible, but I think it is unlikely to disappear everywhere for a few reasons. First, as I mentioned, the radio spectrum is only getting more crowded. We are already talking about 6G. Every time we add a new generation of cellular technology, we are using new frequencies and more complex modulation schemes. The aviation industry moves slowly. It takes a decade or more to design and certify a new aircraft. Consumer electronics move at the speed of light by comparison. There will always be a gap between what a plane was designed to handle and what the latest smartphone is capable of emitting.
That makes sense. The plane is always playing catch-up to the phone.
Right. And second, there is the issue of unintentional emissions. Every electronic device, even if it is not a radio, emits some electromagnetic energy. Even a laptop or a handheld gaming console. This is what we call unintentional radiation. While the standards for consumer electronics are strict, they aren't as strict as aviation standards. If you have a cheap, poorly made device that has a shielding defect, it could be spitting out noise across a wide range of frequencies.
So, even if we solve the cell signal problem, you still have the issue of the literal millions of different devices that people might bring onto a plane.
Exactly. It is much easier and safer for the regulators to just say, look, turn off the high-power radios. It eliminates a huge variable in the safety equation.
I think one thing that would help listeners, and something Daniel touched on, is the lack of catastrophes. Why haven't we seen a plane go down if this is a real risk?
Because, as we said, the planes are very well designed. The risk isn't that a phone will turn the engines off. The risk is that it will interfere with the precision of the instruments during the most critical phases of flight, which are takeoff and landing. And even then, pilots are trained to fly the plane manually if the instruments fail. But in aviation, we don't wait for a catastrophe to make a rule. We make rules based on the potential for a catastrophe. If the probability is non-zero, and the cost of the rule is just asking people to flip a switch on their phone, the safety-conscious choice is obvious.
It is a low-cost, high-benefit regulation. Even if the benefit is only realized once in a million flights, it is still worth it because the cost to the passenger is basically nothing.
Exactly. And I think that is what Daniel was getting at with the overabundance of caution. It is an overabundance of caution, but in an industry where the goal is zero accidents, overabundance of caution is the standard operating procedure.
So, let us summarize the actual risk for Daniel. If he forgets to put his phone in airplane mode, is he going to crash the plane?
No, the plane is designed to handle it. It is shielded, it is redundant, and the pilots are professionals. However, he might be contributing to a noisier environment for the pilots. He might be causing a tiny bit of interference in a navigation sensor that makes it slightly less accurate, and he is definitely causing a headache for the cell towers on the ground.
And if everyone on the plane does the same thing, those tiny little risks start to add up into something that could actually be a problem, especially if the plane is older or if they are landing in bad weather.
That is it exactly. It is about the cumulative effect and the margins of safety. We want those margins to be as wide as possible.
I think the takeaway here is that the rule is a mix of legitimate old-school analog interference concerns, modern spectrum management issues like the 5G altimeter conflict, and a heavy dose of regulatory caution to protect the ground networks. It is not a myth, but it is also not a death sentence if you forget.
Well put. And honestly, it is a good reminder of just how complex our world is. We take for granted that we can fly across oceans and talk to anyone on Earth instantly, but those two technologies are actually in constant competition for the same invisible airwaves.
It is a crowded sky, both for the planes and the signals.
It really is. And hey, if you are listening to this and you have a second, we would really appreciate it if you could leave a review on your podcast app or on Spotify. It genuinely helps other people find the show, and we love reading your feedback.
Absolutely. It makes a big difference for us. And Daniel, if you are listening from your bed, we hope you feel better soon. Thanks for the prompt, even with the cold.
Get some rest, Daniel. And for everyone else, thanks for joining us on this deep dive into the world of aviation and radio waves.
This has been My Weird Prompts. You can find all our past episodes, including our recent ones on electronic warfare, at myweirdprompts.com and on Spotify.
Until next time, I am Herman Poppleberry.
And I am Corn. Safe travels, everyone.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.